Believable proxies of human behavior can empower interactive applications ranging from immersive environments to rehearsal spaces for interpersonal communication to prototyping tools. In this paper, we introduce generative agents, computational software agents that simulate believable human behavior. Generative agents wake up, cook breakfast, and head to work. Artists paint, while authors write. They form opinions, notice each other, and initiate conversations. They remember and reflect on days past as they plan the next day. To enable generative agents, we describe an architecture that extends a large language model to store a complete record of the agent's experiences using natural language, synthesize those memories over time into higher-level reflections, and retrieve them dynamically to plan behavior. We instantiate generative agents to populate an interactive sandbox environment inspired by The Sims, where end users can interact with a small town of 25 agents using natural language. In an evaluation, these generative agents produce believable individual and emergent social behaviors, for example, starting with only a single user-specified notion that one agent wants to throw a Valentine's Day party. The agents autonomously spread invitations to the party over the next 2 days, make new acquaintances, ask each other out on dates to the party, and coordinate to show up for the party together at the right time. We demonstrate through ablation that the components of our agent architecture, observation, planning, and reflection, each contribute critically to the believability of agent behavior. By fusing large language models with computational, interactive agents, this work introduces architectural and interaction patterns for enabling believable simulations of human behavior. 1. Introduction. How might we craft an interactive artificial society that reflects believable human behavior? From sandbox games such as The Sims to applications such as cognitive models and virtual environments, for over 4 decades researchers and practitioners have envisioned computational agents that can serve as believable proxies of human behavior. In these visions, computationally powered agents act consistently with their past experiences and react believably to their environments. Such simulations of human behavior could populate virtual spaces and communities with realistic social phenomena, train people how to handle rare yet difficult interpersonal situations, test social science theories, craft model human processes for theory and usability testing, power ubiquitous computing applications and social robots, and underpin non-playable game characters that can navigate complex human relationships in an open world. However, the space of human behavior is vast and complex. Despite striking progress in large language models that can simulate believable human behavior at a single time point, fully general agents that ensure long-term coherence would be better suited by architectures that manage constantly growing memories as new interactions, conflicts, and events arise and fade over time, while handling cascading social dynamics that unfold between multiple agents. Success requires an approach that can retrieve relevant events and interactions over a long period, reflect on those memories to generalize and draw higher-level inferences, and apply that reasoning to create plans and reactions that both make sense in the moment and in the longer-term arc of the agent's behavior. In this paper, we introduce generative agents, agents that draw on generative models to simulate believable human behavior, and demonstrate that they produce believable simulacra of both individual and emergent group behavior. Generative agents draw a wide variety of inferences about themselves, other agents, and their environment. They create daily plans that reflect their characteristics and experiences, act out those plans, react, and replan when appropriate. They respond when the end user changes their environment or commands them in natural language. For instance, generative agents turn off the stove when they see that their breakfast is burning, wait outside the bathroom if it is occupied, and stop to chat when they meet another agent they want to talk to. A society full of generative agents is marked by emergent social dynamics where new relationships are formed, information diffuses, and coordination arises across agents. To enable generative agents, we describe an agent architecture that stores, synthesizes, and applies relevant memories to generate believable behavior using a large language model. Our architecture comprises three main components. The first is the memory stream, a long-term memory module that records, in natural language, a comprehensive list of the agent's experiences. The retrieval model combines relevance, recency, and importance to surface the records that are needed to inform the agent's moment-to-moment behavior. The second is reflection, which synthesizes memories into higher-level inferences over time, enabling the agent to draw conclusions about itself and others to better guide its behavior. The third is planning, which translates those conclusions and the current environment into high-level action plans and then recursively into detailed behaviors for action and reaction. These reflections and plans are fed back into the memory stream to influence the agent's future behavior. This architecture suggests applications in multiple domains, from roleplay and social prototyping, to virtual worlds and games. In social roleplay scenarios, for example interview preparation, a user could safely rehearse difficult, conflict-laden conversations. When prototyping social platforms, a designer could go beyond temporary personas to prototype dynamic, complex interactions that unfold over time. For the purposes of this paper, we focus on the ability to create a small, interactive society of agents inspired by games such as The Sims. 1. By connecting our architecture to the ChatGPT large language model, we manifest a small society of 25 agents in a game environment. End users can observe and interact with these agents. If an end user or developer wanted the town to host an in-game Valentine's Day party, for example, traditional game environments would require scripting tens of characters' behavior manually. We demonstrate that, with generative agents, it is sufficient to simply tell one agent that she wants to throw a party. Despite many potential points of failure, the party planner must remember to tell other agents about the party, attendees must remember the invitation, those who remember must decide to actually show up, and other possible points of failure, agents in our environment succeed. They spread the word about the party and then show up, with one agent even asking another agent on a date to the party, all from this single user-generated seed suggestion. We conducted 2 evaluations of generative agents, a controlled evaluation to test whether the agents produce believable individual behaviors in isolation, and an end-to-end evaluation where the generative agents interacted with each other in open-ended ways over 2 days of game time to understand their stability and emergent social behaviors. In the technical evaluation, we leverage a methodological opportunity to evaluate an agent's knowledge and behavior by interviewing it in natural language to probe agent's ability to stay in character, remember, plan, react, and reflect accurately. We compared several ablations that limit agents' access to memory, reflection, and planning. We observe that each of these components is critical to strong performance across these interview tasks. Across the technical and the end-to-end evaluation, the most common errors arose when the agent failed to retrieve relevant memories, fabricated embellishments to the agent's memory, or inherited overly formal speech or behavior from the language model. In sum, this paper provides the following contributions: generative agents, believable simulacra of human behavior that are dynamically conditioned on agents' changing experiences and environment. A novel architecture that makes it possible for generative agents to remember, retrieve, reflect, interact with other agents, and plan through dynamically evolving circumstances. The architecture leverages the powerful prompting capabilities of large language models and supplements those capabilities to support longer-term agent coherence, the ability to manage dynamically evolving memory, and recursively produce more generations. 2 evaluations, a controlled evaluation and end-to-end evaluation, that establish causal effects of the importance of components of the architecture, as well as identify breakdowns arising from, for example, improper memory retrieval. Discussion of the opportunities and ethical and societal risks of generative agents in interactive systems. We argue that these agents should be tuned to mitigate the risk of users forming parasocial relationships, logged to mitigate risks stemming from deepfakes and tailored persuasion, and applied in ways that complement rather than replace human stakeholders in design processes. 8. Discussion. In this section, we reflect on applications, future work and limitations, and ethical and societal risks of generative agents. 8.1 Applications of generative agents. Generative agents have vast potential applications that extend beyond the sandbox demonstration presented in this work. For instance, social simulacra have demonstrated the ability to create stateless personas that generate conversation threads in online forums for social prototyping. With generative agents, we can populate these forums, as well as behavior in virtual reality metaverses and even physical spaces as social robots in the future, if paired with multimodal models. This opens up the possibility of creating even more powerful simulations of human behavior to test and prototype social systems and theories, and to create new interactive experiences. Another application area is in the human-centered design process, similar to the intended applications of cognitive models such as GAMS and the keystroke level model. Consider a generative agent that models Sal, the protagonist in Mark Weizer's famous vignettes, based on her life patterns and interactions with technology. In this scenario, the agent acts as a proxy for Sal and learns plausible sets of behaviors and reflections that Sal may exhibit based on her life. The agent can encode information such as when Sal wakes up, when she needs her first cup of coffee, and what her typical day looks like. Using this information, the agent can automatically brew coffee, help get the kids ready for school, and adjust the ambient music and lighting to match Sal's mood after a hard day at work. By utilizing generative agents as proxies for users, we can develop a deeper understanding of their needs and preferences, resulting in more personalized and effective technological experiences. 8.2 Future work and limitations. In this work, we have presented a first instantiation of generative agents. Future research can expand on the modules of the proposed generative agent architecture outlined in this paper. The retrieval module, for example, could be enhanced to retrieve more relevant information given a context by fine-tuning the relevance, recency, and importance functions that form the retrieval function. Additionally, efforts can be made to improve the architecture's performance, making it more cost-effective. The present study required substantial time and resources to simulate 25 agents for 2 days, costing thousands of dollars in token credit and taking multiple days to complete. To enhance real-time interactivity, future work can explore parallelizing agents. Furthermore, with advances in underlying models, we expect improvements in the agent's performance. The evaluation of generative agents' behavior in this study was limited to a relatively short timescale, and future research should aim to observe their behavior over an extended period to gain a more comprehensive understanding of their capabilities and limitations. Varying and contrasting the underlying models, as well as the hyperparameters used for the agents during future simulations, could provide valuable insights into the impact of these factors on the agent's behavior. Additionally, given the known biases of language models, it is possible that generative agents may output behavior or stereotypes that reflect bias. To mitigate this, further work on value alignment will be necessary. Furthermore, as with many large language models, generative agents may fail to generate believable behavior for some subpopulations, particularly marginalized populations, due to data deserts. We also have limited knowledge of the robustness of generative agents. They may be vulnerable to prompt hacking, memory hacking, where a carefully crafted conversation could convince an agent of the existence of a past event that never occurred, and hallucination, among other things. Future research can more comprehensively test these robustness issues, and as large language models become more resilient to such attacks, generative agents can adopt similar mitigations. 8.3 Ethics and societal impact. Generative agents, while offering new possibilities for human-computer interaction, also raise important ethical concerns that must be addressed. One risk is people forming parasocial relationships with generative agents even when such relationships may not be appropriate. Despite being aware that generative agents are computational entities, users may anthropomorphize them or attach human emotions to them. To mitigate this risk, we propose two principles. First, generative agents should explicitly disclose their nature as computational entities. Second, developers of generative agents must ensure that the agents, or the underlying language models, be value-aligned so that they do not engage in behaviors that would be inappropriate given the context, for example, to reciprocate confessions of love. A second risk is the impact of errors. For example, if a ubiquitous computing application makes the wrong inference about a user's goals based on generative agent predictions, it could produce annoyance at best and outright harm at worst. In our instantiation of generative agents, we mitigate these risks by focusing on an interactive video game environment, where such harms are unlikely. However, in other application domains, it will be important to follow best practices in human AI design to understand errors and how they might percolate into the user experience. Third, generative agents may exacerbate existing risks associated with generative AI, for example deepfakes, misinformation generation, and tailored persuasion. To mitigate this risk, we suggest that platforms hosting generative agents maintain an audit log of the inputs and generated outputs, so that it is possible to detect, verify, and intervene against malicious use. While logging will not directly stop such use, and this cannot stop motivated actors that build their own generative agent infrastructures, we suggest that the disclosure risk would reduce such actors' likelihood of engaging in this behavior, and building this architecture oneself can take time, in our case, roughly a year. A fourth risk is of over-reliance, that developers or designers might use generative agents and displace the role of humans and system stakeholders in the design process. We suggest that generative agents should never be a substitute for real human input in studies and design processes. Instead, they should be used to prototype ideas in the early stages of design when gathering participants may be challenging or when testing theories that are difficult or risky to test with real human participants. By adhering to these principles, we can ensure that the deployment of generative agents in the wild is ethical and socially responsible. 9. Conclusion. This paper introduces generative agents, interactive computational agents that simulate human behavior. We describe an architecture for generative agents that provides a mechanism for storing a comprehensive record of an agent's experiences, deepening its understanding of itself and the environment through reflection, and retrieving a compact subset of that information to inform the agent's actions. We then demonstrate the potential of generative agents by manifesting them as non-player characters in a Sims-style game world and simulating their lives in it. Evaluations suggest that our architecture creates believable behavior. Going forward, we suggest that generative agents can play roles in many interactive applications ranging from design tools to social computing systems to immersive environments.